All right, now we're going to look at how you can teach multiplication with base 10 blocks. I would really encourage you, if you're in an elementary school and you're teaching multiplication, work with base 10 blocks first. That goes for addition and subtraction as well. But specifically in here, we're going to talk about how you multiply with base 10 blocks. So you guys know that you should remember the basic setup. You've got your hundreds, these little long skinny ones are tens, and then these little tiny ones are your ones. So we're going to multiply. We're going to start off with a nice easy example here. 3 times 13, which is 3 groups of 13. So I'm going to put down 3 groups of 13 base 10 blocks, and I'm just going to draw this one for this video. So here's a 13. There's a 10 and 3 ones. So this is 13, 13, 13. That's 3 groups of 13. So let me just kind of label. This is 13, 13, 13, and we're basically adding them together, right? We're adding all of those together. So what you would do, what we kind of naturally do, is you would lump all the long skinny ones together. So you would have like 3 long skinny ones, and that would make 30, right? Because 10, 10, and 10 makes 30. And then you would have 1, 2, 3, 4, 5, 6, 7, 8, 9 little tiny ones. And you would do 30 plus 9, and you would get 39, right? So it's really easy to see. This isn't a terribly complicated one, but you group together your 10s, you group together your 1s, and you can see pretty easily that this one is 39. So then if we use an expanded algorithm with partial products, remember partial products means we're going to break apart the second number. So I have 3 groups of 13. So I'm going to rewrite the 13 as 10 plus 3, because that's what it was. It was a 10 and then 3. And I had, if you distribute, 3 times 10, so I had 3 10s, and then I have 3 3s, which is exactly what we're showing right here. 3 10s and 3 little groups of 3. Well, this is 30 and this is 9, and so we come up with 39. So if you've done it with the base 10 blocks, then when you write it down on paper, it makes a lot more sense on paper if you kind of understand what's going on, kind of for those kinesthetic learners that like to use their hands. And then when you go to the standard algorithm, it makes a little bit more sense where these numbers are coming from. The multiplication algorithm is really kind of a strange algorithm. We say it's so complicated, only kids can understand it. So you start this way, right? You go 3 times 3 is 9, and then suddenly you do this diagonal. Why? Because your teacher told you to, right? We're all good students. We're like, yeah, I'll just do it because the teacher said so. You do 3 times 1, and that's 3, and we get this magical 39. But let's talk about what just happened. This 3 times 3, that was the 3 groups of 3 ones. That's your 9 ones. And when you do 3 times 1, it's not really 3 times 1, it's really 3 times 10. That's what that 30 is. And that's why you have to scooch over and put it in the tens place, the 3, so that all the places line up. But what you just did is you distributed 3 to the 3, 3 to the 10, just like what we did up here. So I think by looking at it this way kind of all at once, it really makes you understand that this isn't just some random method that we use that just magically gives you the right answer. I think it's important to understand where these numbers are coming from, and if you've seen it here, it makes this make a lot more sense. And then just math makes more sense in general.